In the last video, we looked at taking a complex number and dividing it by an imaginary number. And we rationalized the denominator to eliminate the radical in the denominator. Well, in this video, we're going to look at one more case of division of complex numbers. But in this case, we will have a complex number in the denominator as well. So something like this. 2 plus 3i divided by 4 plus 5i. Now, we want to do the same kind of thing. We need to eliminate the radical from the denominator. However, our approach is going to have to change just a little bit, because if we simply take the trick we used last time and multiply numerator and denominator by I, we're going to run into an issue. When we go to multiply the denominator by I, we would wind up with 4i plus 5i squared. Well, here's our I squared, and we know that's going to become a real number. But this still leaves us with an I, so we have a bit of a problem. Simply multiplying by I no longer works. There has to be something that we can multiply by that will eliminate this problem and get rid of the radical in the denominator. This thing that we're going to use is something called the complex conjugate. It's called the complex conjugate. Complex because it's going to be a complex number. And conjugate refers to changing of the signs in between the two parts. So the complex conjugate, if a complex number is a plus bi, it would be a minus bi. We simply change the signs in between the real and the imaginary portion. So if our original denominator is 4 plus 5i, the complex conjugate of that would be 4 minus 5i. So to eliminate this radical in the denominator, we multiply by the complex conjugate, 4 minus 5i. Now let's see what happens when we do this. I'm going to start with the denominator because that's the important part. We have to make sure that the radical in the denominator is gone, that we are left with no i's in the denominator. Remember, we have to multiply completely. So when we multiply 4 plus 5i and 4 minus 5i, we have to distribute. 4 has to be multiplied by both parts. So 4 times 4 is 16, and 4 times negative 5i is negative 20i. Then we take the imaginary portion. 5i also has to be multiplied by the entire complex conjugate. 5i times 4 will be a positive 20i, and 5i times negative 5i is a negative 25i squared. Now, I'm not convinced about this yet, so let's take this denominator out one step further before we look at the numerator. Negative 20i plus 20i, if we combine those, we're left with 0i. So we don't have to worry about that middle part at all. Those i's are gone. I squared, we know, is negative 1. So this negative 25i squared is really just negative 25 times negative 1. So our denominator simplifies down to 16 plus 25, that negative 25 times negative 1. Well, this looks good. We're down to a real number in our denominator. No radical left, no imaginary. So now that we've done that, let's go back to the numerator and see how it will simplify. We have 2 plus 3i that has to be multiplied by 4 minus 5i. Our real portion, 2, multiplied by the complex number. 2 times 4 is 8. 2 times negative 5i is negative 10i. Then we take the imaginary portion, the 3i, and multiply it by our complex number. 3i times 4 is a positive 12i. 3i times negative 5i is negative 15i squared. Now to simplify this, negative 10i plus 12i, that's going to combine and give us a positive 2i. This negative 15i squared, we know I squared is negative 1, so that's going to become positive 15. So we have 8 plus 2i plus 15. And we can do a little bit more combining The 8 and the 15, the real portions combined, will give us a 23, and our imaginary portion is 2i. The denominator, 16 plus 25, will give us 41. Oh, 41, not 4i. Checking between our numerator and denominator, we have no common factors. There's nothing that is a common factor of 23, 2, and 41. So this is the simplified form of 2 plus 3i divided by 4 plus 5i. Let's look at one more example. This time we're going to deal with 8i divided by negative 6 minus 3i. Again, our goal is to eliminate the radical in the denominator. This I cannot remain. So we multiply by the complex conjugate. Now remember, the complex conjugate is the form of a minus bi. The only difference is that we change the sign in between the real and the imaginary terms, or the sign on the imaginary term. So our complex conjugate is negative 6 plus 3i. So we multiply numerator and denominator by that, because as long as it's the same thing, it's the equivalent of multiplying by 1. Now let's multiply. In the denominator, the real portion times our complex number. Negative 6 times negative 6 is positive 36. Negative 6 times 3i is negative 18i. The imaginary portion, negative 3i, times the complex number. Negative 3i times negative 6 is a positive 18i. Negative 3i times positive 3i is negative 9i squared. So our denominator, the negative 18i and positive 18i add to be 0. The negative 9i squared, well, I squared is negative 1, so that's the same thing as positive 9. 36 plus 9 is 45. So our denominator is now simply 45. Looking at the numerator, this multiplication is easier. We simply have to multiply the 8i times the complex number. So 8i times negative 6 is negative 48i, and 8i times 3i is positive 24i squared. Well, we know I squared is negative 1, so that just makes this negative 24. We write real first, so negative 24, then the imaginary, minus 48i. Looking for common factors in between these, we actually do have one. We have a common factor of 3. So we can divide 3 out of each of these terms. Negative 24 divided by 3 leaves us with negative 8. Negative 48 divided by 3 will be negative 16, and we still have the I. And negative 45 divided by 3, or not negative 45, positive 45 divided by 3 is positive 15. So this fraction reduced to negative 8 minus 16i divided by 15.